All right, this is video number 2 for August 15th and August 16th. Hopefully you've watched part 1 and we developed that sine of pi over 4 is square root of 2 over 2 and cosine of pi over 4 is square root of 2 over 2. Now, if you go back to video part 1, we're going to do the same thing as we did for 45 degrees, but we're going to do it for 30 degrees. So here on our unit circle, we have 30 degrees would be out here. So I'm going to draw the line out to 30 degrees. And we're going to make a right triangle like we did with the first one. Now I'm going to go through this one a little bit quicker. So that would be 30 degrees. It's still the unit circle, so our hypotenuse is still 1. We're going to be looking at this angle, but we know that 30, 90, that would be 120. So we would have 60 left over. That's going to be important for what we do in the next video, part 3. Developing our unit circle. Now, in class, what we said is this is still on the x-axis, so we call this x. We don't know what that is. This dotted line is y. All right, this is up and down. And I gave students in class this. This is going to be 1/2. There is a way you can develop this pretty quickly, but just for time's sake for the video and for time's sake in class, we didn't go over that. But now we want to solve for x. So what we're going to do is the same thing we did in the first problem in part 1, is we're going to use Pythagorean's theorem. So I'm going to make a bullet here. So we have a squared plus b squared equals c squared. I'm going to set it up. So I'm going to let that be x. So we have x squared, b squared would be 1/2. And c squared would be 1 squared. Now I would actually encourage you to pause the video here and try to solve it on your own and then check it. Because I am going to solve it. I'm going to try and explain each step that I take. But this might help you understand, help brush the cobwebs in terms of solving equations. So if you want to pause it, do it. I would recommend that. If not, here we go. 1 squared, so that's going to be 1. 1/2 squared. So if we have a fraction and we're squaring it, we can actually square the numerator and denominator. So 1 squared would be 1, 2 squared would be 4, and then we have x squared. Now if we keep solving, we're trying to isolate the x squared term, so we need to move the 1/4. So we'll subtract 1/4 from both sides. And 1 minus 1/4, I'm going to do that here real quick. 1, if I want to write that in terms of fourths, is 4 over 4. And then 4 over 4 minus 1/4 would be 3/4. So this is going to be 3/4. And then to solve for x, I have x squared. The inverse of squaring something is square root. X is equal to square root of 3 over, because I can do the same thing we did in part 1. If I have a square root fraction, take the square root to both numerator and denominator, and I'm going to say this is equivalent or the same thing as x is equal to square root of 3. If we put that in the calculator, it's just square root, it would be 1 point something, so we just keep that as square root of 3. But we do know that the square root of 4 is 2. So there we have it. And similar to what we did last time, this is our x coordinate. Boom. Which means that this point here, if I use these two, would be square root of 3 over 2. That's my x coordinate, and 1/2. Okay. Now, I'm going to talk through sine and cosine. I'm not going to do a whole calculation like we did in part 1. I'm just going to talk through it. Kind of like we do with cosine. So I'm going to say sine of pi over 6. Well, if we look here, this is pi over 6 or 30 degrees. And sine is opposite over hypotenuse. Well, if I'm opposite of this angle, opposite would be y, or 1/2. So it's 1/2 and hypotenuse is 1. So 1/2 over 1, or 1/2 divided by 1, would just be 1/2. Similar thing for cosine. Cosine is adjacent over hypotenuse, and the adjacent side is square root of 3 over 2. So adjacent over hypotenuse would be square root of 3 over 2. All right. So I would recommend putting this point on your big unit circle. You'll have time to do that in class on Wednesday or Thursday. But this is what sine of pi over 6 and cosine of pi over 6 are. Now, what we noticed here in class is, if you look at square root of 3 over 2, it happens here. Same thing with 1/2. And in general, cosine is always going to be our x-coordinate. If you notice here, it's our x-coordinate with our ordered pair. And sine is going to be our y-coordinate when we're looking at the unit circle. Okay. This is the end of part 2. I'll do 2 more parts, so continue on to do the last few parts of the guide notes.